Refraction of light at a curved surface.
A lens is an optical system with two refracting surfaces. The simplest lens has two spherical surfaces close enough together that we can neglect the distance between them. Lenses are basically of two types, convex lens and concave lens. Terms related to lenses. Optic center O. It is the geometric center of the lens. Center of curvature 2F. It is the center of the imaginary spherical surface of a lens. Principal axis. It is the imaginary line passing through the optic center and center of curvature. Principal focus or focal point F. When a parallel beam of light is incident on a convex lens after refraction, converge at a point called principal focus. Or, when a parallel beam of light is incident on a concave lens after refraction, it appears to diverge from a point called principal focus. Focal length. It is the distance between the optic center and the focal point. Power of a lens, P. The reciprocal of focal length of a lens is called power of a lens. The SI unit is diopter.
Rules for obtaining images formed by lenses. The image is formed at that point where at least two refracted light rays meet or appear to meet. Rule 1. A ray passing through optical center proceeds undeviated through the lens. Rule 2. A ray passing through first focus or directed towards it after refraction from the lens become parallel to the principal axis. Rule 3. A ray passing parallel to the principal axis after refraction through the lens passes or appears to pass through focus.
Images formed by convex lens. If the position of object is at infinity, the position of the image is at focus f2. The relative size of the image is highly diminished and point-sized. Nature of the image is real and inverted. If the position of the object is beyond 2f1, the position of the image is between f2 and 2f2. The relative size of the image is diminished and the nature of the image is real and inverted. If the position of an object is at 2f1, the position of the image is at 2f2. Relative size of the image is same size and the nature of the image is real and inverted. If the position of an object is between f1 and 2f1, the image formed is beyond 2f2. The relative size of the image is enlarged and the nature of the image is real and inverted. If the position of the object is at focus f1, the position of the image will be at infinity. The relative size of the image is infinitely large or highly enlarged, and the nature of image is real and inverted. If the position of the object is between focus f1 and the optical center O, the position of the image will be on the same side of the lens as the object. The relative size of the image is enlarged and the nature of image is virtual and erect. Images formed by concave lens. If the position of the object is at infinity, the position of the image will be at focus f1 and the relative size of the image is highly diminished and point-sized. The nature of the image is virtual and erect. If the position of the object is between infinity and the optical center O of the lens, the position of the image will be between focus f1 and the optical center O. Relative size of the image is diminished and the nature of the image is virtual and erect.